Okay, so this is just a test run. So right now I have three magnetic reed switches inside the PVC. They're just all linked together. And then I have a small magnet inside of this tube. So this tube can be sealed off and filled with foam just to make sure it's floating. So one option we have is, like we talked about a little bit in class, just an array of the reed switches running all the way up here and just testing which one is closed at any given time. So right now the closest I can get, you can see I've got the PVC marked off in inch increments, and that's about the best I can do with the magnet. It wants to close the circuit a little bit too soon before it's right over the reed switch, so I can only get about an inch accuracy out of this. Even if I tried moving them closer, they'd start lighting up simultaneously. But you can see the LEDs are all popping on, corresponding to whichever reed switch is closed. And reed switches are pretty cheap. I think it's like 70 cents for, if we went specifically with this setup, 70 cents per reed switch. So you could say 32 of them. 32 of them in series, or not in series, but an array of 32 of them, then run that through an encoder. Just a 5-bit data bus coming into the Arduino. We could easily, use that to process what specific height we're at. We just have to make sure that we're not getting two LEDs lit up at once. But this is pretty reliable and pretty robust as far as it's entirely sealed off. So you're not going to have any holes drilled through the PVC unless we have to run that extra line for the water flow sensor. But the fewer holes you have to drill in PVC, the more reliable it's going to be over the lifetime of the product. And those reed switches, once they're in place, should be pretty good. We can even maybe fill the PVC with foam, the good stuff foam. Let it expand in there just to make sure that they're all secure in place. But this has got a little bit of play, and it looks like it's working pretty good. And once this is in place, the user's going to have a hard time breaking this. The other option would be to run the reed switches. I'll have to draw up the schematic to run them all like an array of 32 resistors, all parallel with each other, and then just a reed switch in between each successive connection, so that as you move up that array of reed switches, whichever one in the series is broken, you're going to be able to measure the voltage difference between that and all of them in parallel. As you start taking these resistors out of the circuit, the overall resistance is going to go up, so you can use a voltage divider and capture that voltage. So that's another option where we don't need to run an encoder. We can just run straight two wires in Arduino and measure the analog voltage difference as that keeps going up. So it does away with that encoder circuit. It makes it a little bit more complicated inside of the pipe itself, but that's this is just one option we have.